Hi everyone, I'm Dr. Kiran Raavi, working as an assistant professor in the Department of Electronics and Communication Engineering, MLR Institute of Technology, Hyderabad, India. Today we are going to discuss about metal oxide semiconductor FET, that is shortly MOSFET. So let us see the overview of today's presentation. Start with the introduction to the MOSFET, internal structure of MOSFET, so different types of MOSFETs, and we'll see the N-channel depletion mode MOSFET and its characteristics, conclude with the summary. So we know FET, field effect transistor. So MOSFET is a family of FET. FET is a three-terminal device which consists of gate, drain, source, and it has got two PN junctions, and it's a voltage control device. In contrast to the BJT, BJT is a current control device because output current is controlled by the input current. Let us say IC is equals to beta IB. In case of CE configuration, if you consider the output current IC, collector current is equals to beta times base current IB. Therefore, we can say BJT is a current control device, BJT. Whereas in this case, in FET, the output current is controlled by the input voltage. So that is, for example, the output current ID in case of FET is proportional to function of gate to source voltage. So if gate to source voltage is changed, output current can be controlled. So therefore, FET is a voltage control device, and it is a unipolar device because its operation depending upon either electrons or holes. So, and then in this we have to create one channel for the flow of electrons or holes. So if the channel is, how can we differentiate N channel, P channel? So if the operation depends on electrons, then we can say it is a N channel JFET. If the operation depends on holes, then we can say it is a P channel JFET. So the charges present in the FET establish an electric field which controls the conduction path of the output circuit without need of direct contact between controlling and controlled quantities. So that is the basic principle. So there is no virtual, it is like virtual. So there is no direct contact between controlling parameter and controlled parameter. So here controlling parameter means VGS and controlled parameter is ID. So MOSFET, metal oxide semiconductor, can be classified into two types: enhancement mode MOSFET and depletion mode MOSFET. Again, this enhancement mode MOSFET can be classified or subdivided into N channel and P channel enhancement mode, and depletion mode MOSFET is subdivided into N channel and P channel DMOSFET. So here MOSFETs have characteristics similar to JFETs and additional characteristics that make them very useful. So there are other additional applications, are there additional characteristics or properties which shows by the MOSFET, so which is useful in many applications compared to FET, because particularly switching speed of MOSFETs are very high compared to FET. Also, MOSFET also called as metal IZ FET, that is insulated gate MOSFET, and thus as a gate is insulated from the channel. So the basic principle is by applying transverse electric field across an insulator deposited on the semiconductor material, then the thickness and hence resistance of the channel can be controlled. Right? So types of MOSFET, depletion mode. What do you mean by depletion mode? The controlling field reduces the majority of charge carriers both in N and P channels. So that is called depletion mode. So it reduces the majority of charge carriers. In enhancement mode, the application of electric field increases the charge carriers. So that is the basic difference. In depletion mode, the charge carriers decreases, and in enhancement mode, the charge carriers increased. So these are the different symbols for BJT. So BJT and FETs. Here are So you can differentiate BJT symbols with FET and MOSFET. So let us start with the N-channel depletion mode MOSFET. N-channel depletion type MOSFET has characteristics similar to those of ZFET between cutoff and saturation, that is IDSS. IDSS stands for output drain current when gate is short circuited. Drain current when gate is short circuited, or VGS is equal to 0. So drain has reached saturation level. Drain current reaches saturation level, and also has the added feature of characteristics that extend into the region of opposite polarity of VGS. So you can observe the basic structure of N-channel JFET in depletion mode. N-channel JFET depletion mode has the basic structure you can observe from this figure. So in N-channel we have to use P substrate. Okay, here we have N-channel developed under SiO2 layer. So this is SiO2 layer. Under SiO2 layer we have N wells. N wells are under drain and source terminals, and they are connected metallically. So there are some holes. Through these holes the drain and source terminals are generated, and between we have SiO2 layer. So it acts like an insulator, and on body substrate is another terminal. So this terminal and source terminal are internally connected. Here these N-typed regions are connected via N-channel. This N-channel is connected to the gate via thin insulating SiO2 layer. So insulating SiO2 layer is very thin. There is no direct electrical connection between the gate and channel. So you can observe this is the gate and this is the channel. So there is no direct contact between gate and channel. The N-doped material lies on P-doped substrate, so that may have an additional terminal connection called substrate SS. So coming to the operation of N-channel depletion mode MOSFET. So N-channel depletion mode means the carriers will be reduced. So here when gate is shorted, VGS is equals to 0. So gate to source voltage is 0 volts, and some positive voltage we have applied across the drain and source. So this is drain and source. So this is VDS. Now an attraction of the free electrons of the N channel for the positive voltage at the drain. So here drain is being positive and it is connected to positive. So forward bias condition. So this is positive and this is positive. So in such case, electrons from the channel, the free attraction of free electrons of the N channel for the positive voltage at the drain. This results current similar to that of flowing through in the channel of JFET. So if you observe the JFET construction, so this is N channel and this is P types, heavily doped P type materials, which forms, you can say, gate, and this is drain, and this is source. So between source and drain we have connected some VDD. Okay, so in such case, so we are not giving any voltage. VGS is equals to 0. Gate to source voltage is 0. So that means gate is negative. So negative means 0 means lower potential. Lower potential is connected to positive. So reverse bias. So reverse bias means, so obviously the depletion region increases in this case. The same procedure here. So here electrons are from the channel attracted towards the drain. So in opposite to this electron flow, there is a drain current. So drain current will flow opposite to the electron flow this way. Okay. So you can observe the characteristics here. So VDS, if you increase the VDS value for different values of VGS. So VGS is positive here, and when it is positive, so you will have maximum drain current through the FET And then when VGS is equal to 0, we have this value IDSS, drain to. So the drain current reaches a saturation level, and that is IDSS. And if you further decrease, if you apply negative voltage, so let us discuss about the characteristics one by one later. So let us see the next case, second case, operation. So coming to the second case, that is gate voltage is less than 0. So if you are decreasing the gate to source voltage, so that is this one. So if you decrease this voltage, what happens here? And we are applying some positive voltage VDD. An attraction of free electrons of N channel for the positive voltage at the drain. The results current similar to that of flowing in the channel of the JFET. Based on the magnitude of negative bias voltage by VGS, a level of recombination between electrons and holes will occur. So if you increase the gate negative value, this value, so what happens? This is being negative and electrons repelled by this negative terminal, gate terminal, and so that means they move towards the P substrate. So therefore, reducing the number of free electrons in the N channel available for the conduction. Actually, these electrons are N channel. In the N channel means what? The majority charge particles are electrons. So electrons will be participated in the conduction part. So due to this gate voltage, negative gate voltage, those electrons are repelled by this negative gate voltage and they move to away from this silicon layer. So the more negative the bias, the higher recombination takes place. Recombination means these electrons move away from this gate terminal and attracted towards the P substrate, and there will be chance of recombination takes place. So electrons hole pair takes place. The application of positive gate to source voltage has enhanced the level of free carriers in the channel. So free carriers in the channel. So that is the basic idea of operation of this N channel depletion mode MOSFET when gate to source voltage is negative. So here you can observe when VGS negative, this is VGS is equal to minus 2 volts. So here corresponding voltage current, drain current is constant, and then VGS is equals to minus 2 volts. Further, your drain current is also decreases, and after that, so even you increase the drain to source voltage, there is no increase in the current. Current will be constant. Only gate to source voltage increases, changes, then ID also changes. So this is drain characteristics and this is the transfer characteristics. Here we have two modes in transfer characteristics, enhancement mode and depletion mode. When VGS is equals to less than 0, then we can say depletion mode. So there the charge particles will be reduced, and whereas if VGS is positive, there will be a chance of negative charge particles will be enhanced or increased. So that's all for today's session. So we have started with the introduction to the MOSFET, and we have discussed the internal structure of MOSFET and what are the different types of MOSFETs, N channel and P channel, enhancement mode MOSFET and depletion mode MOSFET, and we particularly discussed N channel depletion mode of MOSFET and its VI characteristics. So that's all for today, and next topic may be probably operation of N channel E MOSFET, enhancement mode MOSFET. Thank you.